Welcome everyone to Introduction to Globus Flows Part 2. I am Ada Nicolaitis. I am a manager for the Automate team. Our team is working on a number of different products inside of Globus that we kind of think of as this constellation of different resources and tools that you can use to speak to different types of automation questions. And so those include services like Globus Flows, which we're talking about today, Globus Timers, the Globus SDK, the Globus CLI, and Globus Search. So a number of powerful pieces within there that you can kind of combine together to create these complete solutions. But for today, we are going to be talking about Globus Flows. And in part 2, we are going to be diving into how flows work. And in particular, we're going to kind of address a few key questions to help build up your mental model of what flows are doing, what they're capable of, and what's happening when you run a flow. So first off, we'll talk about exactly what's happening during the course of a run. We are going to be looking at what happens when a run needs additional authorization and becomes inactive. And we're going to talk a bit about what goes into creating a flow. Keep in mind, if you want to dive deeper into these topics, there is part 1 that is available. For those of you who are joining live, you've just seen it. We will have some additional Q&A at the end, and we also provide a lot of additional information in the doc site that will be really useful if you start journeying into authoring your own flows. So keep an eye out for those, and we'll probably take another peek over at that in a little bit to show you some of the resources available there. So when automating with Globus Flows, let's talk about what happens when you run a flow, simplified version. Ultimately, when you run a flow, there are a number of different things that are going to occur when you first start that launch. And the first thing is authorization. Is the user allowed to access this flow? Have they been given permission? Do they have a role? Are they properly logged in? And so once they've authorized it, if they pass authorization, we move on to the next step, which is checking to their input to ensure that it is valid. And in particular, kind of mentioned input schema briefly in part 1. We're going to talk a little bit more about that today, not in super detail, but the idea being is that the input schema is part of the flow, and it is provided by the author, and it helps to define what types of input is required, what types of input is optional, and what are the valid parameters on what a user can supply there. And so this helps make sure both that users are putting in, valid input, and that the flow can make some assumptions about the state that it is starting from. If the input is valid, we proceed on to creating a run. And so a run is a new resource that represents the combination of a particular flow definition at that point in time, as well as the input that you provided it and any roles that you've assigned on it to allow people access to it. So it's going to create that run, and it'll have the specified settings recorded in there, and then it will start the first action in the flow. And so that action will be invoked. And when this kind of brings us into what we think of as the core run loop of Globus Flows, and you'll sort of see how it progresses through this and loops over this over and over again until the flow completes. And so fundamentally, we're going to start that action. We're going to wait for the action to finish. And then when the action is done, we are going to say, is there another action after this? If there is no additional action after this, well, then we're done. If there is, then we go back and we invoke the next action, and we continue to follow that path through the flow, following each next subsequent action. If it isn't, we're done. And there's also kind of another possibility in here, which is that we might run into an error. So if you don't catch the error, you will move to a fail state. And so effectively your flow run will fail, and you can go back to, say, the event log and get additional information there to see what happened in the course of running that flow. There are some types of errors that will automatically retry on your behalf. And in addition to that, there is also the ability to catch errors in each of your states and then choose to do something instead of failing it. So you can send them to other actions and create more kind of complex layered handling of those situations. So much like an application, you can build up more and more options and handle more and more scenarios as you go. But this is sort of the core run loop of flows and how these progress. So at this point, the run is finished. And that is really kind of the simple model of what's going on each time you run that flow. What happens though when additional permission is required in the course of a run? So in some cases, the run is going to do its best. The flow service really is going to do its best when you start the run to figure out all the permission that might be required in order to accomplish it. And so, as you saw when I launched that run from the Globus web app, I was asked to consent to a number of different actions that it was going to perform. And so I could see what permissions I was giving it. And so in many cases, that's sufficient, and it will do that up front. And I don't need to think about it again. But in some cases, it may discover as it's going that additional authorization is needed. This is frequently due to accessing a mapped collection somewhere in the flow. And part of the reason why this happens is often flows doesn't necessarily know in advance because flows doesn't have any internal knowledge of the state of the collection. It might not necessarily know what access that it needs a priori. And so in those cases, what will happen is when the flow encounters an action that requires additional authorization, it will find out and it will pause the flow and put it into a state that we call the inactive state. Generally at this point, the runner, so the person who started that flow run, is going to receive an email if they have an email address associated with their Globus identity. And they can also view the run in this state in pretty much all of the apps that support flows. And so, as we talked about before, from the CLI, from the Python SDK, from the web app, you'll be able to see your runs that are in this state and work with them. In this case, you can choose to abandon that run. You could start a new run. You could do something else. That's totally fine. But you also have the option to resume, which is a way of granting the additional authorization that that run needs in order to proceed. So in the course of resuming, what will happen is you will be asked for whatever the additional piece is, which will generally be data access on that mapped collection. And then you will be able to continue the operation of your run from there. A couple pro tips, though, that are useful to understand that are kind of trip up folks sometimes. The first pro tip is to resume with the same application that started the run. So you want to go back to that original application that you used to launch the run in order to grant it the permission. So if you were in the CLI when you started the run, you're going to want to go back to that same CLI session. If you were in the web app, you're going to want to go back to the web app. If you were in the Python SDK in a custom application, the application that, but it will be sort of you interacting with that application. You can resume it from another application, but when you do, the thing that's important to know is that that additional permission that you give doesn't get associated back with the application that originally launched the run. So if I launched it from the CLI and I resumed it in the web app, the next time I launch the same run with the same settings from the CLI, it still won't have that permission because I gave it actually to the web app. And so in that case, you want to make sure that you go back to the CLI so that way each time you launch new runs from the CLI, you won't get asked for that permission again. So that's a good thing to know. If you find you're getting asked for the same permission over and over again, hopefully this kind of plants a seed in your memory that this is a thing to look out for and to potentially go back and revisit how you are resuming those runs. Pro tip number 2. Use guest collections when possible. That's our recommendation for automation. Guest collections avoid this circumstance, and so because of the way that they work, you won't need additional authorization to access those in the course of your flow. So those two things together give you some strategies. Is more information on this in the doc site pages. So if you look through the flows docs, you can find some more information if you encounter this, and particularly if you're an application author and you're trying to figure out what are the best ways to handle this circumstance for your users. So things that are good to know about the inactive state. What are the pieces that make up a flow? There's really two key components. And as an author, you have control over both of those. So the first key piece of the flow, the first component, is the definition. And the definition is fundamentally, it is a series of instructions, of actions that are going to be performed over the course of its operations. So it's a list of these operations, the actions you're going to perform, transformations, so ways that you may shape your data for each step in the flow, and conditions, choosing different paths through the flow based on the state of your particular data. And so based on, observing different values that you have in there. And so this is kind of the programmatic logic of what is going to happen and what is going to be performed by the flow. And the other piece, as I've alluded to a couple times, and we'll finally talk about at least a little bit more, is the input schema. And the input schema is really expressing requirements for the data that is provided when you start a run. There are three key benefits to the input schema. The first of those is it prevents errors due to bad input. And so in these cases, that is both an affordance for you as a flow author, because you can reason about less potential states for that data to be in. And so it makes it a little bit easier to write the flows if you can create some stronger guarantees about the data that's coming in. But it also helps users. If you have users that are launching these flows manually, then it also allows them to potentially catch errors before the flow starts rather than as the flow is running and some bad data is encountered. In addition to that, it allows you to display that guided input in the web app. So you all saw that in part one, that rich web form that gives users an easy set of controls that they can walk through to provide the required input to their flow. The way that guided input is constructed is by using the input schema. And so it's actually generated from that. So the better an input schema you provide, the better of a guided input experience you can potentially get. And then third is flow validation. And flow validation is a relatively new feature that is still in beta. And this provides more detailed feedback. And the stricter your input schema is, the better that feedback can often be. Enhanced flow validation, we're going to talk about in a little bit the types of things it can catch, but know that the information provided by the input schema informs flow validation. And so even while you're authoring the flow, you're getting more useful information to improve the correctness and robustness of your flow definition. All right, so we've alluded to it for a while. You've seen some peeks at it. What is in a flow definition? First of all, you'll see that we have a JSON document here. And so fundamentally, flows are defined in JSON documents. And they have a number of components. And this piece that you see here, we're going to walk through each bit of it in a little bit of detail. But what you see here is, in fact, a complete flow. So even though I showed you some that were quite long and quite involved, it is possible to have flows that are simpler. And in fact, there can be use cases for flows as simple as a single action, when you might want to provide a bespoke interface around that action and some user constraints. So there are a number of ways where even a simple flow like this can be a powerful tool. So there are a number of fields in here that are worth talking about that make up your flow. First off, there is start at. And so this case, it says start at my transfer. My transfer is the name of a state in the flow. And we'll look at that in a second. But effectively, it just tells the flow, as the name suggests, where it is going to start. What is the first state or action that it should be processing? Next up is the comment. The JSON document format does not allow for built-in comments. So there is an affordance in here that you can add your own comments that'll be preserved in the flow definition. And so that way you can provide a little more indication of what particular, what the flow is intended to do and what particular states are intended to do. And then in addition to that, at the top level, our third field is the states field. So you'll see the states field is an object, and that object is composed of actions, and they are keyed by their name. So just as we saw in start at my transfer, we see the my transfer action is now defined here. So what goes into this piece, or a couple different bits. First off, there's a type. And so this is the action type. And so as I mentioned, there are other types of states that you can and probably will use as a flow author, and they can do some useful things. In particular, I've mentioned the past state. There is the wait state. There is the choice state, which allows you to drive branching logic. And there is also a fail state. So if you want to explicitly error out at a point based on a certain condition that doesn't otherwise trigger an error, that can be a way to do it. Or sometimes it might be that you catch an error and provide a nicer failure mode. So there are a number of potential uses for those too. Other types, we have, in addition to actions, we have one other one that we won't talk about today, but you can find some additional information in the doc site. It's called expression eval. An expression eval allows you to put some kind of short one-liner expressions in here to do some transformations on your data and some additional processing and restructuring. And so there's a lot of use cases where that might be helpful in doing some data prep between different stages. In addition to that, next up, we have the action URL. So why a URL? One of the things we haven't really talked about so far, but it's helpful to know, is that actions call out to things called action providers. We call them APs for short. But action providers are effectively, in most cases, thin services that expose an API that's structured in a way that flows understands. And so this can be a way to make services that aren't necessarily natively flows compatible with it by exposing all of the APIs that it expects in the shapes that it expects. So that way it understands kind of how to, what the requirements are of that action provider, and what are the different valid fields that it can interact with, among other things. So this is the URL to that action provider. In this case, you can see it is to transfer.actions.globus.org/transfer. And so this is how you perform a transfer inside of flows. Important to note, it is possible to create your own APs. So you can create your own action providers if you want to connect your services to flows and make them accessible through flows. We're not going to get into a ton of detail about that here, but there is more detail available in the website. And of course, you can always reach out to us if you're starting down that path, and we can provide you, some pointers in the right direction as well. So once you have decided which type that you are, and so we're doing an action, we've given our action URL so we know which AP is going to be providing that action. Then we specify parameters. And so parameters is an object, and parameters contains the arguments that that action provider needs in order to do the work that it is supposed to do. And so in this case, what we'll see is that this information inside of parameters is actually the sort of minimum set of arguments that you need to give for a transfer to be completed. And so we have a source endpoint, a destination endpoint, and then an array called data, which contains some objects, including a source path and a destination path. And so inside of here, you will see that's kind of a minimum viable thing. For each action provider, they will accept different arguments like any API does. And so in those cases, there will be different things. And one of the resources that we provide over here on the doc site, you can see an example of some of these hosted action providers. And so you can see information. And so for instance, if we were to go to the transfer action providers, you can dive in here and you can see more about what some of the particular things are that are supported for that action provider, and even some example usages inside of a flow. So if you want to look at some example flows in there, that provides you some ways to do that. So hopping back, I'm gonna check back in here. Next up, actually, let's call out one other thing. Inside of here, you'll see an interesting bit of notation, both inside of that data array and also inside of the result path. So this notation, when you see the $sign at the end of a field in an action, that means that it's actually referring to something in the run's built up state. So it's referring to something that's coming from elsewhere. In this case, these are actually both coming from our input for this flow. So these are referring out. Other fields always refer to a particular path. And so when you look at result path, this is telling it where to put the output of this action. This notation here, this $sign dot, and then you see things. This is called JSON path notation. So there's more information about kind of what you can do with JSON path, but it is effectively driven by kind of dots and brackets to access your objects and arrays, and to reach into that stored state to feed the output from another action, or to feed some of your input into other actions in the course of operating. More to talk about there, but that's JSON path notation is a really important thing to be aware of as you start building up flows and you want to have these actions operating on the output of other actions, or dealing with user input. In addition to that, you can see that there is a wait time specified. A wait time is kind of a timeout. So effectively, the wait time specifies how long an action should wait for it to complete. If it exceeds that wait time, then the action will throw an exception, and if it's not caught, it will cause the run to fail, or you can catch it and choose something else to do instead. So in this case, this is in seconds. So 300 seconds are provided here, so approximately 5 minutes. One important note, we talked about the inactive status before. So when a run becomes inactive, an inactive run does not count against this wait time because that action is not in progress. It can't start yet. So in fact, we give you up to 72 hours to resolve the inactive time. The wait time only applies to while the action is actively running. And then here you will see one final thing. In this case, it is the end field. If there were more actions to perform in this, it would be a next field. And so it would be next, and the value would be the name of the next action to go to. But in this case, it is end, and so the value is true, and that just tells it that the flow is done. You can't have multiple ends because your flow can branch. It's possible there are multiple ways to get to the end. But that is the basic components that go into defining states inside of your flow. So this is all of it together, and gives you a little bit of an idea of kind of what the shape of some of this looks like. Now, as I mentioned before, one of the things to think about as well is flows doesn't exist in a vacuum. And so one of the things that we've tried to be very conscientious of is that making sure that there are good ways to interact with flows through all of our interfaces, depending on what your needs are, because this is a tool that might fit into a number of different places for the type of problem that you're solving. And so in addition to being able to access it through the web app, as we saw in part 1, you're also able to access it through the Globus CLI, which can be great for things like ad hoc scripting or integration, or running as part of a process driven by, say, an instrument. You might also have use for the Python SDK, which allows you to do things like incorporating it into applications, services, or data portals, for instance. So a number of different possibilities there as you start to combine some of these different products together. In addition to that, I want to briefly mention Flow's enhanced validation. So I mentioned this a little bit before, in particular mentioning why the input schema can be helpful for validation. So enhanced validation is a new offering in beta from us. And part of what this does is exposed in the Flows IDE, the Globus CLI, the Python SDK, and via that REST API that we talked about before. Um, and what this does is it allows you to catch types of errors that just looking at any individual state is very difficult to do. Effectively, what it does is it allows it to look at all of the possible paths that you could take through the flow during the course of a run. And in all of those possible paths, find conflicts between them. So saying, well, wait a second, if the data is, this particular type on this path, then this other path can't possibly work. And so you can find these much more nuanced cases that can only occur under certain conditions. And so this becomes a really powerful way as you are authoring a flow to get feedback and get information about bugs that you might not have been able to spot initially and that may have only cropped up under certain very specific inputs. So yeah, invalid references to input. It can also find things like invalid parameters supplied to action. So we talked about the idea that parameters field, each action will have different requirements and different available fields that you can use in there when you are specifying the action. So this will help find ones that are invalid and can be really useful in those cases because you don't need to run it in order to spot those errors. And also as well conflicts in particular state type. So keeping an eye on the clock, I just want to recap this a bit in review. Ultimately, we talked about a handful of key concepts today between part 1 and part 2. We talked about the idea of flows, these sequences of steps to perform as part of a reusable hosted automation. These contain both definitions and input schemas as the key pieces that you use to create a flow. We also talked about runs, where a run is a particular invocation of a flow with a specific input. We talked about actions, which is an operation performed during a flow run that interacts with other services and resources. And we talked about action providers, which is a service layer that makes APIs compatible with the Flow's ecosystem.